Let's talk about lockout/tagout. OSHA has had a standard for this since way back in 1989. Most facilities have the written procedures, and workers definitely get trained on it. So why are people still dying? It just doesn't make sense. And that's a tough question we're really going to dig into today.
Really think about that for a second. The law, OSHA Standard for the Control of Hazardous Energy, has been around for more than 30 years. Its whole purpose, the entire reason it exists, is to stop machinery from unexpectedly starting up while someone's doing maintenance. And yet, here we are. Maintenance workers are still getting crushed, electrocuted, and killed by equipment that was supposed to be completely safe. So you have to ask, why does this keep happening?
Because the numbers, well, they're just devastating. According to the Bureau of Labor Statistics, contact with equipment and machinery led to 779 worker deaths in just a single recent year. 779. Every single one of those represents a terrible, catastrophic failure. These are the exact events that lockout/tagout is designed to prevent.
So to really get to the bottom of this, here's how we're going to break it down. First, we'll cover the basics of hazardous energy. And trust me, it's about a lot more than just flipping a breaker. Then we'll dive into the 5 real-world ways these programs fail. We'll look at what happens when OSHA has to investigate a fatality, what a good program actually looks like, and finally, what every single worker out there absolutely must know to keep themselves and their coworkers safe.
Okay, let's start with the absolute fundamentals here. Most people hear lockout and their brain immediately goes to electricity. And yeah, that's a big part of it, but it's a dangerously incomplete picture. The real threat is any kind of hazardous energy that can be released when you least expect it.
That's exactly right. You've got to account for at least 6 different types of energy. Of course, there's electrical, but then you have mechanical energy, stored in a compressed spring or a big spinning flywheel. You've got hydraulic pressure just waiting in a fluid line, pneumatic pressure in a compressed air system, thermal energy from a scorching hot pipe, and you can't forget about gravitational energy, a heavy part that's suspended and could fall. Any one of these, all by itself, can be fatal.
And OSHA is super clear about what employers have to do to control all these energy sources. The law demands 4 main things. First, a written program that lays out the company's entire policy. Second, and this one is so important, documented procedures for each specific machine, not a generic one. Third, they require annual inspections of every single one of those procedures to make sure they're being followed. And fourth, proper training for the employees doing the lockout and for those working nearby.
Okay, so if the rules are that clear, where's the disconnect? Where do these programs actually fall apart on the shop floor? It's almost never just one little mistake. It's usually a chain reaction of system failures. We've pinpointed 5 common and often fatal ways this happens. Let's get into the first one. Failure number 1 is the partial lockout. This happens all the time. A worker isolates one energy source, usually electricity, but they forget about the others. So, imagine a maintenance tech locks out the main electrical disconnect on a press. The lights go off, it gets quiet, the machine seems totally dead, but what they missed is the pneumatic line holding a heavy ram up in the air. As they're working, that stored air pressure slowly bleeds off, and that ram comes crashing down. The machine was not at a zero energy state. Just cutting the power isn't a guarantee of safety.
The second failure point often happens during group lockouts. That's when you have multiple people working on the same machine. Now, OSHA has very specific rules for this. You need a designated lead, and every single worker has to put their own personal lock on the group lockbox. The rule is simple: your lock, your life. But here's the scenario that can turn deadly. A team thinks they're done. One worker, assuming everyone's clear, takes their lock off. But another technician is still inside the machine, maybe out of sight doing one last check. That simple, honest mistake can be fatal.
And that leads us right into the third failure, verbal authorization. This is when a supervisor just says, "Hey, it's fine, I shut it down, go ahead and get in there." A worker might trust their boss, but that verbal okay means absolutely nothing to the machine. It is not compliant with the law, and it is not safe. The only thing that guarantees that machine stays off is your own physical lock on the disconnect. Period. End of story.
And that brings us to failure number 4, locking out the wrong thing entirely. So how does that even happen? Well, most of the time, it's because the company is using a generic one-size-fits-all lockout procedure for every machine in the whole plant. But every machine is different. A procedure that works for press A might be totally wrong for press B right next to it. Not having these machine-specific procedures is one of the top LOTO violations that OSHA cites, year after year after year.
The 5th failure, and maybe the trickiest one, isn't really about a procedure, it's about culture.
There's a concept for this. It's called the normalization of deviance. It's when a shortcut, like reaching into a machine to clear a quick jam without locking it out, becomes normal. Somebody does it once, nothing bad happens, so they do it again. Pretty soon, other people see it and they start doing it too. That unsafe act becomes the standard way of doing things, all to save a couple of minutes of downtime. It is a full-blown disaster just waiting to happen, and it's a direct result of production pressure winning out over safety.
So, what happens when that disaster finally strikes? When a worker is killed in what was a preventable lockout/tagout incident, a whole chain of events gets set in motion. And honestly, the consequences for the company can be incredibly severe.
When OSHA investigates a fatality, they are extremely methodical. They'll get on site, secure the area, and interview everybody involved. But the heart of their investigation is going to be the paperwork. They will demand to see that written energy control program. They'll ask for the training records for the worker who died and their supervisors. They'll want to see the log of the last annual inspection for that specific machine's procedure, and they will scrutinize that machine-specific procedure itself. If any of that stuff is missing or isn't up to snuff, you better believe they will find it.
And the outcome of that investigation can be financially crippling. A violation that's deemed serious comes with a big penalty. But if OSHA finds the violation was willful, meaning the employer knew about the hazard and just did nothing or flat out ignored the standard, the penalties just skyrocket. The max fine is $156,259, and that's per violation. In a fatality, it's pretty common for them to find multiple willful violations.
Okay, so we've spent a lot of time on how these programs fail. Now let's flip that around and look at what success looks like. Because a really effective energy control program isn't just about avoiding fines. It's about building a culture where every single employee goes home safe every single day.
You know, the difference between a truly compliant program and a failing one is all in the details. A failing program has one generic LOTO procedure for the whole plant. A compliant one, it has a detailed, written procedure for every single piece of equipment. A failing program might show an employee a generic video once when they're hired and call it a day. A compliant program does hands-on, role-specific training and annual audits of every procedure to make sure people actually get it. A failing program might have a messy bin of shared locks and old tags. A compliant one issues personal, standardized locks to every authorized employee. It's night and day.
And this brings us right down to the individual. It doesn't matter if you're a maintenance tech, a machine operator, or a manager. You have a very specific role to play under the law, and you also have rights that are there to protect you.
Okay, first up is the authorized employee. This is the person who's actually trained and allowed to perform the work and put the locks on. They have to be trained to recognize every hazardous energy source on a machine. They need to understand its type and how powerful it is, and they have to know the exact methods to isolate and control it.
And second, you have the affected employee. This is usually a machine operator or really anyone who works in the area where a lockout is happening. Their job is to be notified before the lockout starts and after it's over. And their number one responsibility is to never, under any circumstances, try to restart or re-energize a machine that's locked or tagged out.
This also brings up a really critical distinction: lockout versus tagout. A lock is a physical restraint. It makes it pretty much impossible to turn something on. A tag, on the other hand, is just a warning sign. It can be ripped off, ignored, or removed. That's why OSHA is crystal clear. If an energy source is capable of being locked out, you must use a lock. A tag-only system is an absolute last resort and requires extra safety measures to even come close to the protection of a lock.
All right, let's wrap this up with the most critical takeaways. Lockout/tagout doesn't fail because people don't know it exists. It fails because of incomplete energy isolation, huge gaps in procedures, and the constant pressure to get the job done fast. Every single energy source, mechanical, pneumatic, hydraulic, not just electrical, has got to be controlled. Your procedures have to be machine-specific, and you must inspect them every year. And never, ever, ever accept a supervisor's word over your own physical lock.
The difference between compliance and tragedy really does come down to the details, the training, and the culture you build. The rules are there for a reason. Following them isn't a suggestion. It's the barrier that stands between a routine maintenance job and a fatal incident. If you want to keep learning how to make your workplace safer, go ahead and subscribe to HSE Study for more explainers just like this one. Stay safe out there.